This question is related to atomic structure of an atom. Chlorine gas has two isotopes which are having a mass number of 35 and 37. State the number and type of each particle in a nucleus. So because each will have chlorine 35 is there and chlorine 37. So if it is chlorine 35, it will have 17 protons and it will have 18 neutrons. Whereas chlorine 37 will have 17 protons, but it will have 20 neutrons. Then complete the electronic configuration for a chloride ion. Chlorine atom having 17, chloride ion will have 18 electrons. So we have to arrange 1s2, 2s2, 2p6, 3s2, 3p. So till now we arrange 3p maximum can have 6 electrons, so 3p6, so total will be 18. Because it's a chloride ion, so it will have 18 electrons. If it was chlorine atom, then 17 electrons will be there. A sample of a chlorine contains 75.53 of a chlorine 35. Calculate the relative atomic mass of a sample. So if 75.53 is chlorine 35, then remaining will be chlorine 37, because as I mentioned, there are two isotopes of the chlorine existing. So to get the average mass of the two isotopes, the percentage of the isotope multiplied by its mass into percentage multiplied by its mass divided by 100. If we have the percentage, because the total will be 100%. So chlorine 35, that is percentage 75.53 multiplied by its mass, which is 35, plus percentage 100 minus 75.53, so it will be 24.47 multiplied by its mass, that will be 37, and divided by 100. So when we simplify this, this will be 35.49 will be the average mass of this isotope. So fluorine has one naturally occurring isotope with a mass of 19. Chlorine and fluorine react to form a trifluoride, chlorine trifluoride. Draw a dot and cross diagram to show the bonding in the molecule. So this question is related to the bonding. We have to represent the structure of a chlorine trifluoride. Fluorine and chlorine both belongs to group 7. But as the number of electrons in the shell increases, it can adjust even more than 8 electrons in the outermost shell. So when we complete the structure, one chlorine is there and surrounded by 3 fluorine atoms. So if fluorine share 1, fluorine shared 1 from that side. Fluorine share 1, chlorine, even though chlorine belongs to group 7, it should share 1 electron only to be stable. But as I mentioned, as the number of electrons increases as the number of the shells increases, the maximum number of electrons which can be adjusted in the shell also increase. So this will have 1 electron shared. Same thing, fluorine share 1, chlorine shared 1. And chlorine belongs to group 7. So as element belongs to group 7, it has shared, out of 7 it shared 3, so remaining 4 will be unshared. And we'll draw the unshared electron of a fluorine as well. Then state in terms of electrons what is unusual about the dot and cross diagram you have drawn. So what is unusual here, that the dot and the cross diagram which we drew here, that we represent more than 8 electrons in chlorine. So like, as you can see, how many electrons are there in chlorine? Outer shell 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are there, like 5 pairs of electrons. And what is the reason for that? Because chlorine is having, like, as the number of the shell increases, the maximum number of electrons which atom can adjust also increase. Like it can, 8 is for stability, but it can adjust more than 8 electron. So what is unusual here, that chlorine is having 5 pairs of electrons, or we can say 10 electrons. So there are 5 pairs of electrons in chlorine. That is unusual here. This part is related to mass spectrometer. Complete a mass spectrum to show the peaks you expect for ClF3. So how many peaks we expect? Like example, because chlorine is having 2 isotopes. So if chlorine is having 2 isotopes, it might have chlorine 35 or it might have chlorine 37. So where do we expect the peaks? If it is chlorine 35 is there. So if it is ClF3, so this will be 35 and fluorine is 19 multiplied by 3. Each fluorine is 19, so 19 times 3. That is 57 plus 35 equals to 92. So this peak we will expect at 92. And the other one, it might be 37. And this will be 19 multiplied by 3. So this will be 94. But what will be the percentage? As I already mentioned, like chlorine 35 was given in the question, that is 75 point something percent, and remaining 25% is chlorine 37. So ratio of the peak will also be same, like one should be 75. One should be like the one which is 92 should be 75. And the one which is 94, that should be 25. This part of a question is related to general gas equation. Calculate using the ideal gas equation that volume in cm cube for 0.02 mole per dm cube of moles of ClF3 at 60 degrees. Remember, unit convergence is always important. The pressure is 1.28 exponent 5 Pascal. We have the formula PV is equals to nRT. So where P is the pressure, V is the volume, N are the number of the moles, R is the general gas constant, and T is the temperature. And temperature should always be in Kelvin. So we will convert the units first. And the last part, we will just substitute in the formula. So temperature, they mentioned it is 60 degrees. So we have to add 273. So it will be 333 Kelvins. Where N representing the number of the moles, which is 0.02. P is the pressure. That is given in the question, that is 1.28 exponent 5 Pascal. V we are finding, and R, the value of R is given 8.31. But remember, whenever we use this formula, we'll always get the answer in meter cube. Like PV is equals to nRT. So V is equals to nRT divided by P. So when we get the answer, the volume which we need, that is always in meter cube. But in the question, we have to convert the meter cube into centimeter cube. So first, we'll find in meter cube, and at the last part, we'll convert into centimeter cube. So we substitute the values. 0.02, R is 8.31, temperature is 303 Kelvin, divided by pressure, which is 1.28 into 10 to the power 5 Pascal, will give us volume, which is 4.32 into 10 to the power minus 4 meter cube. So to convert meter cube, remember, like 1 meter is equals to 100 centimeter, but it is cube. So 1 meter cube is equals to 100 centimeter cube, 100 cube or centimeter cube. So basically, if we want to convert this meter cube into centimeter cube, we have to multiply by 100 cube, or I can say 1 million. So we have to multiply by 1 million or 10 power 6. So when we multiply this will give us the final answer in centimeter cube, which will be 432 centimeter cube. So if in a question, if they give the volume in cm cube and you have to use the formula, then always convert the volume into dm cube. And how to convert meter cube? How to convert cm cube into meter cube? You divide by 100 cube, or we can say 1 million. But here we have to convert meter cube to centimeter cube. That's why we multiplied by 1 million.